This video, we're going to talk about density. So, in this question, it says that Molly wishes to make a lawn ornament in the form of a solid sphere. The clay being used to make the sphere weighs 0.075 pounds per cubic inch. If the sphere's radius is 4 inches, what is the weight of the sphere to the nearest pound? So, they give us the shape that we're working with, which is a sphere, and they give us this number 0.075. And if you know this, next to the 0.075, there are two units. There is a unit for pounds and a unit for cubic inches. So that is the density when you see a number that has two units attached to it. Density is mass over volume. It's the amount of stuff in a specific amount of space. So it has two units. It has the mass unit, that's the first unit here, and it's got the volume unit, the second unit here. So if there is a number that has two units attached to it and it doesn't say explicitly that it is the density, it is the density. Okay, so we are finding the weight of the sphere, so we are finding the mass. They give us the density, so I'm going to plug in the density, 0.075 pounds per cubic inch, and it's important that we write the units because sometimes we are going to need to do conversions in our questions, and writing out the units helps us to see if we do need to do a conversion or not. We're solving for the mass, so I can't fill that in. I'm going to have to find the volume of the sphere. The volume of a sphere is 4/3 pi r cubed, and it tells us that the radius is 4 inches. So there's my volume. I'm going to stick it into my calculator so I can see what it is approximately. So 4/3 pi four to the third power, and that is approximately 268.0826. I want to leave a couple of decimal places until my very last step, so that way I don't make a rounding error by accident. So now I'm going to just stick this over 1 and cross multiply to solve for m. Notice how cubic inches is in the numerator and the denominator, so it cancels out. We're left with just pounds, which is the mass unit. So that makes sense because we are looking for the mass in this question. That makes sense that the volume units would cancel out and we'd be left over with the mass unit. On my calculator, I'm going to multiply the volume by 0.075 by the density. And it says to round the weight or the mass to the nearest pound. So I got approximately 20 pounds. Please pause the video and read the next question. So we are talking about a wind turbine engine and a part for it. The part has a volume of 1,015 cubic centimeters. So they give us the volume already. Steel can be purchased for 29 cents per kilogram and has a density, so they give us the density, of 7.95 grams per cubic centimeters. If they are making 500 of these parts, what is the cost of the steel? Okay, so they give us the density, so I know I'm going to be using the density formula. Density is equal to mass over volume, and the density is 7.95 grams per cubic centimeter. It's important that we write the units because sometimes a conversion is needed, and if we don't write the units, we might not see that we have to do a conversion. Okay, they also tell us what the volume is. The volume was given as 1,015 cubic centimeters. So that tells me in order to find the cost of the steel, we need to find the mass of the steel. We need to basically find out what the steel weighs. Okay, so the volume unit cancels out. We have cubic centimeters in the numerator and the denominator. So if we cross multiply, we will have the mass in grams. That is the unit that is left over. We multiply this on my calculator, 7.95 times 1,015. And that is 8,069.25 grams. So now we have the mass. We need to find how much the cost of the steel is. So it says that the steel can be purchased for 29 cents per kilogram, but we don't have our mass in kilograms. We have our mass in grams. So in order to figure out what the cost is, we need to take our mass, which is in grams, and change it to kilograms. Kilograms is bigger than grams. So we're going from a smaller unit to a bigger unit. So what we're going to do is we're going to divide by 1,000 to convert from grams to kilograms. It's kind of like when we're converting from inches to feet, a smaller unit to a bigger unit. If we're converting 24 inches to feet, that's going to be 2 feet. We divide by 12. So when we're going from smaller unit to a bigger unit, we are going to be dividing. So let's divide by 1,000, and let's see what that is. And I got 8.06925 kilograms. So that is the mass in kilograms. Okay, so now that we know how many kilograms the steel weighs, we can figure out the cost. Since it cost 29 cents per kilogram. So let me multiply the mass by 0.29. And I got 2.34 approximately. And it does say that we're making 500 of these parts, so we are going to multiply by 500. So if I multiply by 500 on my calculator, I get, and my answer is a cost to the nearest dollar, so that's the nearest whole dollar with no cents. I got approximately $1,170. So very important that you write out the units. Otherwise, you won't be able to see that you need to do a conversion if you need to do one. Here's another one. Please pause the video and read the question and try it out. A contractor needs to purchase 500 bricks. The dimensions of each brick are 5.1 centimeters by 10.2 by 20.3 centimeters. And they give us the density of each brick, 1,920 kilograms per cubic meter. It tells us that the maximum capacity of the trailer is 900 kilograms. Can the trailer hold the weight of 500 bricks? Once again, this question gives us the density, so we're going to be using our density formula. Density equals to mass over volume. Let me put in the density. So remember to include units because sometimes you have to do a conversion. And if you don't include your units, it's going to be really hard to see if you need to do one. Okay. We can find the volume even though we're not given it because we're given the dimensions of the brick. A brick is a rectangular prism. So we find the volume, the area of the base times the height. Since the base is a rectangle, that is length times width times height. So our volume is going to be 5.1 times 10.2 times 20.3. So let me do that on my calculator. 5.1 times 10.2 times 20.3. And that is 1,056.006. And my units for that are centimeters cubed. Oh, wait. That's a little problem here because our volume unit from our density and our volume unit with the dimensions that are given are not the same. So that's the units are important. So we actually need to convert. We need to take our volume from centimeters cubed, from cubic centimeters, and we need to change it to cubic meters. So we're going from a smaller to a bigger unit. So when we're going from a smaller to a bigger unit, just like when we're going from inches to feet, from 24 inches to 2 feet, we're going to divide by whatever the conversion is. So the conversion from centimeters to meters is 100, so we're going to divide by 100. So I'm just going to take my volume and I'm going to divide it by 100 cubed. I can't just divide it by 100. The reason for that is I am not in centimeters. I'm not going from centimeters to meters. I'm going from cubic centimeters to cubic meters. So I'll write this on the side. So what I actually have to do to go from cubic centimeters to cubic meters is I actually have to divide by 100 cubed, because the conversion from centimeters to meters is divide by 100. But we're going from cubic centimeters to cubic meters. So let me write down what I got for the volume. Let me write that down over here. So that is approximately 0.001056,006. And now that is in cubic meters. So let's cross multiply to find out what the mass of each of the parts is. And our volume units are now the same, and they're going to cancel out, and we're going to be left over with the mass unit, which is kilograms. So our mass is going to be in kilograms. And once again, it makes sense that the volume units would cancel out because we are trying to find the mass here so we can see what the weight of 500 bricks is going to be. So let me multiply 1920 times that really long number 001056,006, and I got 2.02753. I definitely want to leave a couple of decimal places until my very last step, so I don't have a rounding error. Okay, so this is the mass of one brick, but we're talking about 500 bricks here. So we're going to multiply the mass by 500. And I got 1013 point, this is approximately 766. But the trailer can only hold 900 kilograms. So 500 bricks definitely weighs more than 900 kilograms. It is over 1,000 kilograms. So the answer is no, the trailer cannot hold the weight of 500 bricks, and our work justifies that. Here we have a chart, and this chart is for 4 counties in New York State, and it is asking which county had the greatest population density. Population density is the same thing as regular density, except instead of talking about like how much of an object in a certain amount of space, it's talking about how many living things in a certain amount of space. So how many people, plants, or animals in a certain amount of space, a certain amount of area. So instead of thinking about it as mass over volume, when you're talking about living things, you can think of population density as people, or of course plants or animals, so your living things, over the area, the amount of space, the amount of land. So all we have to do here to find which has the greatest population density is find the population density for each of these places. So we're going to do people, which is the population, divided by the area that they occupy, which is the land area. So on my calculator, I'm going to do the first one, 200,536 divided by 706.82. And I got for the first one approximately 283.7. Okay, for the second one, 280, 150 divided by 801.59. And I got approximately 349.5. So already this second one is more, has a bigger population density than the first one. So answer choice 1 is out already. Let's move forward to the next one. 219,846 divided by 522.95. And that is approximately 420, oh, 0.4, my bad. 420.4. So far, that is the greatest population density. So this choice is out. Just one more to go. 200,635 divided by 811.84. And that is approximately 247. So this one, answer choice 3, has the greatest population density.